this video, we're going to put the pieces together and start to use the textual information that we've worked on to predict earnings. So we have a few libraries here. We've seen them. We're going to read in a new data set, this MDA.CSV. So MDA, I named it because Manager's Discussion and Analysis. So this is just using subsets of the 10K, and it's just a certain section that we're pulling out here. And if you look at the data set, it takes a minute to show up because the text part is a little bit large, but we have the GB key, that's the company identifier we've seen before, the fiscal year, the company name. IB is income before extraordinary items. So this is the net income, the earnings number we've been using before. This is income the following year. So we're going to try and predict this number here. And if you recall, the best thing that predicts the next year's number is last year's number. So we're going to use that. And then this part, the MDA text, includes the text from the MD&A section of the 10K. So you can see a little bit here, some of the discussion. This is where they talk about performance and how things are going in their business and things like that. And so that's for all of these. So all I've done is the text we had used before is now we've put it in a cell in this data frame so that we have a different one for every document. So for Boeing in 2005, we've got their MD&A section. Notice we have Anheuser-Busch 1994, their MD&A section. So we just have documents for each of these companies and years. Then just a quick note. So throughout the code, I've used this here to identify places where you can make changes for the homework, but then also tell you where there are potential places in the script where if you made different choices, you could get different abilities to predict future earnings. So let's start with the easy one. This is using the regular expressions to pull out, make lists of dictionaries or list of words that can then be used to mean something. So here, I'm just using what we had in the code before. So I'm going to call these words positive words, although they're really sort of growth sort of words. And this is negative words. Again, these are really sort of like anti-growth, shrinking sort of words. And so these, as you'll see, aren't the best words for these dictionaries or lists, but I think because you've seen them, it makes it sort of easy. So what I'm going to do then is I'm going to save this original file as a new file, not changing anything. Then I have this pattern that we've used before. So of course, if you use different words here, or you improve the words here, then you can make changes and that would potentially improve what you can capture. And I'm saving this as a new column in the data frame. I'm calling this positive. And notice I'm running that on the text column in the data frame. So what this does is the same things we were doing for a single document. Now it will run these for each document in that column. And then this is the same as we had before. So I create a positive one, a negative one, and then I'm creating a net positive by subtracting them. And you can look in here and see when you do this, I have some with words, 154 more negative words than positive words, and some with 198 more positive words than negative words, and kind of mostly positive, and some near zero on the net. I'm going to put this in. I'm going to try and predict earnings the following year with the sentiment in that year. In year T, the sentiment to predict earnings year T plus 1, and my control is this IB. Now, it shouldn't surprise you that my poorly done word lists aren't going to do very well, but how to do it, I think, is the key point. And in the slides, we'll talk about a lot of different dictionaries that people have used to try and predict things. And so the sentiment measure isn't statistically significant. Earnings is statistically significant. So you could do this with any number of different word lists that you might think of. Now we'll try what would be referred to more as sort of the machine learning approach, or starting down the natural language processing approach. And this just uses what we did in the last video, where we're going to create a bunch of combinations or words, and use those individual words to predict earnings. So when we do this, so I'm going to read this corpus in, and this is the new part here. So I'm creating a new a new set, and I'm going to remove the text part. The reason is I want to create a corpus that includes what are called document variables. So identifiers or information that is about the document, but not to be included in all of the text. So I'm creating this corpus from the text column here. So it's going to create an individual document for every row. But then I'm going to put in the other variables that are in this data frame. So that's the identifiers and the earnings numbers, and I'm going to call those doc variables because those are the ones that are at the document level, not at the not within a document. So when I do this, you can see, take a little bit here. So this is the first document. It has this many tokens, so that means splitting up sort of into words, this many sentences, and then the document variables is what these are called here. A few things that are important here. Notice here in this one, for Anheuser-Busch, in that year, 1994, it only has 2 sentences. This one only has 1 sentence. So we have something going on here, and what this one thing that should make us think is we don't have the same sort of documents, and really what happens in some of these is we haven't captured all of their discussion. So this is a little bit of a problem, and so I'm going to remove some of these, and I'm going to show you how to do that. Of course, we could leave them in, it's just that these won't work as well. So we can count the number of sentences. This is a quantita function that says count the number of sentences in this corpus. So it's going to go through, so again, corpus is each of these texts. So I'm going to create a new object, test, that is just a count of these. So down here it says, notice we have the same sentences here, 785, 2, 785, 2, and then I'm going to do what is called a corpus subset. So I'm going to put some restrictions on the documents that I have in here. You can do any variable that you created or the document level variables. So we could, instead of doing this test that we just did, we could do, for example, a fiscal year requirement or some sort of IB requirement. Here I'm going to say test is greater than 25, so I'm going to only keep documents that have at least 25 sentences. I'm going to save this as corpus 2. And notice what happens here. Oh, come on. Is we had 500 documents, now we have 439, so we dropped 61 documents because they didn't have at least 25 sentences. So we go through the normal tokenizing. So we've seen some of this before and some of it is new. So remove punctuations, numbers, symbols, separators. And we did this before, only keep words, or tokens is what they're called, but words that are at least 4 characters, and don't keep any that are more than 20 characters. And so those are the ones we're going to keep. Here's a new one we're going to do. And the reason that this is important is when we do this, and you could try just running this part, what happens is you get many thousand, you get like 3,000 words. Well, if we have a few hundred, well, we haven't done those yet, but I'll show you in a minute. If we have a few hundred observations, but thousands of words, you can't actually train a model on that. You have to narrow down the words because you have to have fewer variables than you have observations. And so we need to restrict the words somehow. Now, if you had a corpus of 100,000 texts, then a couple thousand words is no problem. It'll take a long time to run, but it's not really a problem. So sometimes you may want to restrict it down, sometimes you may not, but you have to be careful that you don't have too many tokens compared to the number of observations you have. So one way that we're going to do that here is I'm going to restrict. So here it says, keep. It's sort of like that. Here we're going to select token select. We're going to keep ones only that mention a pattern, that have a certain pattern. So here it has to have revenue star means anything, revenue with anything after it, expense with anything after it. We could change this. There are different ways to do it where we could explicitly use regular expressions, but we won't do that here. Padding put back in a space. Then the window is how many words around revenue and expense do we want to keep? So here I'm just saying, let's keep 2 words around revenue and around expense. So we can make this list bigger. We could choose different words. We could change the window around those words that we're keeping. But notice what this is going to do is it's going to severely cut out a lot of other words, and we're going to use a sort of smaller set of words. If you didn't do this, you'd still have a huge list of words. That's also fine. So notice the minimum characters of 4 and max of 20. We could adjust that. We can adjust these words. We can adjust this window. Then we're going to lower everything and word stem again. Then the new part, another new part is we're going to do this n-grams. This is going to increase the number of tokens, but it also helps show that we can start to capture a little bit more of what the document is saying. And what that's going to do is take these revenue and expense items with the 2 words around them and combine any 2 combinations. So if this is revenue and one of these is like sales revenue, then it'll combine these 2 into a what is called an n-gram token, and that'll be used as if it were a single word. So if we look at what shows up from doing that, so we have, for example, expense and across. Of course, it's the stem of that, and operating and expense. So that operating expense sounds like something that we would use that is a certain item. And then we have others where revenue maybe didn't show up. So asset liability, well, that's because it was next to something that said expense or revenue. And these will be used as different word individual tokens. And then we can, so notice over here, we've got a bunch of these tokens in each text, okay? Then here we're going to do what we did before, remove stop words, which now these combinations won't be part of those, but some of the individual words could be. And this is a new part. Once we have multiple documents, we can then say we only want certain tokens that show up more or less within documents. So this is something you could adjust as well, but let me talk through what these mean. So the minimum term frequency, we saw that before. I'm saying here that it has to show up that term, so it could be within a document or across documents, but that term has to show up at least 50 times in the corpus we have. That means we want something fairly frequent. This doc frequency, so that's saying how many documents is it in. This is how many terms show up. This is how many documents does it show up in. So here I'm saying it has to show up in at least 50 of those documents. And it cannot show up in more than 250 of those documents. So that's going to restrict. So the minimum is going to say it needs to be something that shows up fairly frequently. So that's going to remove ones that show up in only a few documents. This one says if it shows up in every document, we don't think it is going to help us distinguish between documents, so we're going to remove that. So what we end up with then is this DFM, this document frequency matrix. Again, all of this stuff showing up in there. Then we can then take that, and what that's going to do is we've got a restricted set of variables, of terms that it's going to look better than we had before. And because we chose revenue and expenses, maybe these are the things we can understand. This is the word cloud. So notice when we look at this, there are a few more things that are sort of meaningful here. Revenues increasing, that's a huge deal. Expense decreasing, that's a fairly big deal. So those make sense, right? When they're talking about revenue increases or expense decreases, those are things we understand from an accounting language. By the way, these work pretty well at predicting earnings, and I have a paper on that. There are other ones that maybe aren't quite as nice. Revenue from, well, that combination doesn't make a lot of sense, but that's okay. Pension expense, that's just a specific item. Increasing revenues here, which is the other direction of these. So, it would be nice, and we could go about that as making this one and this one the same, but we'll leave them here. So they're counting as different items, although we would want those to be the same items. Segment revenues, right? So some of these, this starts to make sense about what is being discussed in these documents. And most of them are talking about revenue increases. Some are talking about general and administrative expenses. Well, that's just a specific item. So that, there would be things that maybe we don't expect to be meaningful in here, but others that really should be. So now we need to set it up as a data frame again that we can use for our models. So I'm just going to combine columns here. I'm going to name this column IB lead 1 from the document variables, IB from the document variables. So again, we're pulling from this data frequency matrix. And then the data frame of DFM, that's going to do is take all the tokens in the data frequency matrix and put them into the data frame. So when I do that, well, okay, another thing, then when we have that, I need to remove this document ID because I don't want that to show up in my models. So the document ID says this is document 1, 2, 3, 4, 5, so I'm just removing that. Once we have that, we can go look at this text DF. Notice it has IB next year, IB this year, and then these word combinations that we're going to use. So interesting enough, the single word tokens get dropped out with all of the requirements that we put in. So they should also show up, but that comes, I think, partly because of this max document frequency. It gets rid of a bunch that because, for example, revenue shows up in every single document, but revenues combined with something else does not. And when we do all of that, notice we have, so text.df, we have 147 variables. So that's small enough. So if this were still bigger than the number of observations we have, we might want to start narrowing it down even more and requiring other things. We could make the max doc frequency lower, or the minimum document frequency higher, or higher on the minimum turn frequency, or some of these other things up here. But now we've got the columns down to something manageable when we do these, the model. So following what we did before, I'm going to create a training and a testing data set. I'm just putting text in here to tell me it's based on this text stuff we've been doing. And then we're going to run our models based on the training data and then test it on the testing data. So just a little bit of a warning, these methods, we're gonna introduce one other thing. All of this together, you're gonna have a large number of columns, especially if we're a bigger data set. And I'm gonna do something that restricts, it's going to do a variable selection. We talked about variable selection before, but here's an automated way to do variable selection in a machine learning way. That adds another layer of complexity that will take a while to run. So again, this part here, you're going to run it a couple of times. So you want to make sure you've got everything right before you run this. And then this is, depending on how many cores and how fast your machine is, this is going to take a while to run. So I think on mine, it takes an hour or two. So let me talk about what's different here. So you've seen this part before. This RFE, and I gave some web links here. It's recursive feature elimination, which is basically like a stepwise variable selection model for different methods in this caret package. And we're going to do it for the XGB tree. So it's going to add certain variables, take other ones out, and it's going to keep trying this. Well, the reason it takes a while is because, well, if we have XGB tree, which takes a little while on its own, and then you're going to select which columns to include in there, that takes a while. So let me go through what's here. So this is just like something we had before. The function is RFE. And the data frame and sizes here is telling it how many columns to include. So I'm just going to say 5 and 15. So choose the 5 best ones, and then the next time choose the 15 best ones. At the end, it's just going to choose which of those works better, 5 or 15. So we could mess around and try different numbers of those. Then this is new. So this RFE control is just like the control command we had before, but it has a couple of different things here. This functions, we're using caret functions. That's sort of a general term for different types of models. That is going to be applied to this XGB tree method, which we had before. And then these controls are things we had before as well. So use this repeated cross-validation. If we make these bigger, then it's going to take a longer time, although it should fit better out of sample. So, you can mess around with these, but I would be careful unless you have lots of time to let it sit there. Don't make them, really big. Once we run all of this, what happens is we can then do the prediction like we would before. So I have this model object. I take the training data and this model object to do a predicted next year's earnings based on, so IB is one of these columns. So that was prior year's earnings and all of the text stuff. And so that'll predict, that was what we called fitted before. It's just predicting on training data. Then we can see how that worked. So next year's earnings on predicted, which includes prior year's earnings, and just see how that worked. Well, here it says it has a 96% R squared. That's super high. Part of the reason that is we have a lot of variables relative to the, so 148 and 263 observations. If we're really close, or if we have the same number as of columns as observations, we can perfectly predict. So this is one of the problems. But then we've narrowed it down to 5 and 15. Well, it chose the ones that get closest because of this. So we would expect it's going to do worse out of sample. It also happens that this training data just happens to work. The random sample that we got of the training data is really highly correlated between prior year and the next year's earnings. So that's unusual. Okay, but so that gives us an idea. Then we can do the same thing with the testing data. So we're going to use the same model on the testing data, come up with this predicted next year's earnings. Let's start with the benchmark, which would be, let's only use prior year's earnings. Notice this is 60% R squared, so it's still quite high, using only just the earnings. So then what happens when we use the machine learning model with the words and the earnings together? Notice our R squared went up to 72%, so we went from 60% to 72%. That means by adding the words to it with the machine learning method, then our prediction is better than just using IB. Of course, there are lots of factors involved in this, so we may, depending on how you adjusted these words or how you did the training, it could do worse, it could do better. What I want you to then try and do on the homework is just, go look back through and see if you made different choices, how these are going to change. So, do you end up with better or worse on the training data? When we get to the testing data, how does that affect it? For sure, you're going to get some that do worse. You may get some that do better. All I'm interested in is you trying to explore and understand, these choices that happen along the way. What I would also do is, let's say you make, you change this list, or you do something different with this n-grams. So by the way, you can do the n-grams could be 3 words, 4 words. The problem is once you do that, then you start getting lots and lots of tokens. So we have to be careful with this as well. Or you could change some of this here. So all of that together will give you something different. I would, try a few things, but then along the way, maybe check what the word cloud looks like, look at the data a little bit to try and understand what's happening. I hope what you get out of this, though, is the sense of how to start to incorporate, if you wanted to use words and text in your models, how you might go about doing that, and some ideas about how to fine tune that. All right, have fun with this. Thanks for your semester. I hope all of these together get you much more comfortable in R and give you the tools or get you exposed to the tools that will help you be successful in the future, and give you some seed information that you might want to exploit.